question 2 of, let's start with question 1. Let's do question 1 because I can't remember if I started already. So we'll start with question 1. Had an error with the wrong camera being turned on. So, electrician's theory examination, 18th of November 2017, question 1. So, question 1, we have calculate the line current drawn by a 3-phase 400 volt inductive load of a 19 kilowatt power draw of 0.875 power factor value. So, first, we have our 3-phase power formula. Power equals √3 times V line, which is our 400 volts, times by our I line, which we do not know, times by our power factor, which is our 0.875. Now, we need to divide by what we want to cancel out. So we divide by the square root of 3 times 400 times 0.875. Now, whatever we do to one side, we have to do the other side of the equal sign. So √3 times 400 times 0.875. Now, square roots cancel, 400 volts cancel, the 0.875s cancel. So we end up with, and our P, we should have put in is 19,000. So we'll now have I line from here equals 19,000 divided by √3 times 400 volts times power factor, which is our 0.875. Calculator. My phone. So we have square root of 3 times by 400 times by 0.875. I'm doing the bottom first because that's technically in a bracket. And we get 606.2177. We get our 19,000 divided by shift answer, shift equals to get answer, I should say, and we get 31.34 amps. Helps if I have that in a better position. Now, we look at our answer sheet for question 1. We have 31.34 amps, which agrees with what we have here. Now, we move on to question 2. Question 1, part B. Question 1, part B is as follows. We have an alternator has 48 poles and it is to feed the 230/400 volts 50 Hz MEN distribution speed. Distribution system. Calculate the speed of rotation of the alternator to enable it to feed into the distribution system. Now, the formula you will have, and if you look in your book, is NS equals 60F over P. Personally, not a fan of this formula. I like to use RPM equals 60 times Hertz over POP. Same exact formula. The difference is F equals the unit Hertz. NS is synchronous speed, and this is RPM sync. It's the same thing. NS and RPM are interchangeable. And I don't like this P because this P is supposed to be pairs of poles. And the reason for that is all magnets come with a north and a south. So they come in pairs. Now, our equals 60 times our 50 Hertz over our pairs of poles. We had 48 pairs. So we end up with 48 poles, 24 pairs of poles. 60 times 50 is 3,000. Then if we do our 3000 divided by our 24, we'll get 125. So 125 revs per minute, which is our answer to that one. And if we check the answer sheet, that is what it shows, 125 RPM. Now, carrying on with the maths section of the paper, we move on to question 2. First, wipe this out. Question 2. We'll return to theory questions later on. This is a maths class, essentially. So, for question 2, we have a 150 kVA 3-phase delta star connected step-down transformer, and it has a phase turns ratio of 47.8 to 1, and the primary is connected to 11 kV. Now, I'm not even going to read the questions on this. I'm going to start by drawing out my pictures. So it's 150,000 VA, because it was 150 kVA. It is delta star, right? It has a ratio of 47.8 to 1. It has a connection of 11,000 volts. Now, we do our lines coming off here. We will have a voltage here. We will have a voltage here. We will have an amperage here. And we will have an amperage here. And we want to work out these values. That's almost guaranteed you will want to know all this information. So all we've been told so far is 150,000 VA, 3-phase delta star, 47.8 to 1, and 11,000. So to start with, we're going to get our 11,000. We're going to divide it by our 47.8. That gives us 230.1255. So my voltage here is 230.125. And then we multiply that by the square root of 3, and that will give us our voltage between these two lines, which is our 398.589, so 59. Now, as for current, that is our V line. Our formula for current is VA, which is our 150,000, divided by root 3 times V line. So it is our 398.59. So we multiply this by the square root of 3 from our calculator, and then we get 150,000 divided by shift answer, and we will get 217.27 amps. Now, going to our other one, it's 150,000 once again, divided by root 3 times 11,000. So we're going to do the bottom first because it's implied that it's in brackets when we draw it this way. So root 3 times 11,000 gives us 19,000, and 150,000 divided by answer gives us 7.87 amps. Now, we have just drawn up the picture. We haven't answered any questions, but now we have a look at our questions. We are going to be asked, calculate the secondary phase voltage of the transformer. Our secondary phase voltage is 230.125. We check the answer sheet. Question 2. We have 230.12. They're out because of rounding areas. 125, it should actually become 13. B, they're asking us what is the secondary line voltage instead of the phase voltage. We've got 398.56. We have 398.59. They're out because of rounding issues. We actually have the more accurate answer. Primary I line. So this is our formula for the current here. We have 150,000 divided by root 3 times 11,000, giving us our 7.87 amps. I line secondary, that is our 150,000, divided by root 3 times by our V line, and that gives us our 217.27 amps. Once again, they're out because of rounding and putting in 0.3. Question E is less obvious. We actually have to look at the question. And our question E is we have a 25 kilowatt balance load with a power factor of 0.7 supplied from the secondary side of the transformer. So in order to answer this question, first we need to get rid of all of this. So that goes in space to right. So first we need to get our voltage. So we've got 11,000 and then divided by 38. If I remember the number right. 47, sorry. 47.8 equals our phase voltage, and so now we want to multiply that by the square root of 3 to get our line voltage. So to put that back in our calculator here, we've got 11,000 divided by 47.8 times by square root of 3, and we will get our line voltage, the line of 398.59. So 589, which is why it rounds up to 59. And now we've got 25 kilowatts at a power factor of 0.75. So power power equals, and then we've got this root 3 times V line times I line times cos theta. Now we know that this is 25,000 that they gave us in the question, equals root 3 times 398.51 59 times 0.75. We want to divide and times by I line. And then we divide both sides by root 3 times our V line, which is our 395.8, times by 0.75. We do the same on this side, root 3 times V line times 0.75. The root 3's cancel out, the V lines cancel out, the 0.75's cancel out. We end up with it just equaling I line. I line equals, and that is our 25,000 divided by square root of 3 times V line times 0.75. So I currently get my V line in there. I'm going to multiply this by root 3, and I'm going to multiply it by 0.75. Doesn't matter on order of operations because they're all multiplicated. And now we get our 25,000 divided by answer, and we get 48.28 amps. We go and look at our question, our answer sheet, they have 48.29 amps. It is subtly different, but that is because they have rounded mid-question. We have the exact answer because we started with the source numbers. Moving on to the next question. So we're going to look at question 4. So question 4, we have calculate the motor output power required to drive the full load torque of 142.63 Newton meters. Going to get my formula sheet out to help. I am out of practice for this one. We are working with So we have our formula now, which I was trying to remember. P out, or external, equals. And now we have 2 pi nt over 60. Now, with this question, P out is our output power in kilowatts, or watts, I should say. 2 and pi, same thing we already know. N is our NS, so our RPM. N equals RPM, T equals torque. And so now we have our output power, which is what we're trying to calculate. So power equals, and then we have 2 times pi times RPM times by my torque, which is 142.63. And then what I missed, going back to question 4, because my challenge for why I got stuck is we have a power, we do not know the power, and we have an RPM. We are trying to calculate RPM. That gives us 2 unknown variables. That side. But if we look at our motor nameplate, we can see that we were given it 30 horsepower. So 30 times by 746 equals 22380 watts. So now we've got 22380 equals 2 pi RPM times 142.63. We now have to divide both sides by 2 pi RPM. Oh, wait, not RPM. That's what we're trying to work out. 2 pi times 142.63. We have to do the same to both sides. So 2 times pi times 146. 142.63. The 2's cancel out, the pi's cancel out, the 142's cancel out. So now we have RPM equals 2 pi 142.63 and 22380 divided by that. So RPM equals, and we have let's do it, 2 times pi times 142.63 equals, and then we have 22380 divided by shift equal, well, shift equals to get the answer, and that gives us 24.97. Should have read the nameplate. Stop and restart.